Imagine an orchestra. Each instrument produces a different sound. The violin is high-pitched, the drum is deep, the flute is light, but they're all playing at the same time. And if you're standing in the right spot, you can hear all of these sounds at once. Now, what if I told you this? There's an orchestra like this in the solar system, too. Jupiter sometimes roars like an ocean storm. Saturn emits a low, deep rumble. Earth's magnetic field occasionally produces strange, almost electronic sounds. And the sun hums like a giant, constantly vibrating instrument. But you've never heard these sounds, because your ears can't detect these frequencies. These sounds are transmitted as radio waves, plasma vibrations, and magnetic field fluctuations, far beyond the range of human hearing. But scientists recorded these signals, and then they converted them into audible frequencies. And when they heard them, they were shocked. Because these sounds weren't random. They weren't chaotic. Each planet had its own unique sound, a signature, a character. Today, we'll tell you about those sounds, those signatures. Welcome to the Solar System's orchestra. Let's take a step back first. We said there's no sound in space. That's still true. But what do we actually mean when we say sound? Sound is a pressure wave that propagates through a medium. Air, water, metal. It needs a medium to travel through. There is no such medium in space. Therefore, there is no sound in the classical sense. But the things emitted by planets are different. Magnetic fields, radio waves, plasma waves, electromagnetic vibrations. These can propagate through space because they don't require a medium. Electromagnetic waves travel through a vacuum. And these waves have a characteristic. They have frequencies. That is, they repeat at a specific rhythm, at specific intervals. Scientists capture these frequencies and convert them into a range that the human ear can hear. That is between 20 Hz and 20,000 Hz. This is called sound conversion, or sonification. And the result is, in the truest sense, a sound. It's not artificial. It's not made up. It's an exact conversion of the original signal. So what do the sounds of each planet sound like? Let's go through them one by one. Let's start with Jupiter, because it's the noisiest planet in the solar system. Jupiter's magnetic field is about 20,000 times stronger than Earth's. This massive magnetic field causes charged particles, electrons and ions, surrounding the planet to spin at incredible speeds. These spinning particles emit radio waves. In 1955, Bernard Burke and Kenneth Franklin detected these waves for the first time. At the time, they were looking for something else, but Jupiter's emissions were so strong that they kept picking up on their antennas. When these signals were later converted to audio frequencies, the result was astonishing. Sometimes like an ocean wave, sometimes like a storm, sometimes erratic, harsh, sudden bursts. And these sounds have a source, one of Jupiter's moons, specifically Io. Io is the most volcanically active body in the solar system. It's constantly erupting volcanoes, its surface constantly spewing lava, and all this activity interacts with Jupiter's magnetic field. This interaction generates electric currents, and these currents, in turn, trigger radio waves emanating from Jupiter. So, in a way, Io is like the guitarist playing Jupiter's music. Have you ever thought about a connection like this? How can a moon's volcanoes shape the sound of a planet? Saturn is perhaps the most famous planet in the solar system. Rings. Every child recognizes Saturn by its rings. But did you know that these rings make a sound? Saturn's magnetic field is weaker than Jupiter's, but still much stronger than Earth's. And this magnetic field is in constant interaction with its rings. The ice particles and dust in the rings follow the magnetic field lines. As they do so, they emit electromagnetic waves. The Cassini spacecraft orbited Saturn from 2004 to 2017, and during that time, it recorded the radio signals emitted by Saturn. When these signals are converted to audio frequencies, they produce a low, deep, continuous hum. Sometimes rhythmic, sometimes irregular, but always deep. It's as if Saturn is breathing. And here's an interesting detail. Cassini discovered that the period of Saturn's radio emissions, that is, the time between repetitions, changed over time. This suggests that the planet's rotation period is more complex than previously thought. So Saturn's sound even provides us with information about the planet's interior.
Now, let's go back home. The Earth has a voice too. It's called a chorus, or koro in Turkish. And this name is no coincidence, because these sounds, emanating from the Earth's magnetic field, truly resemble a chorus of birds. In the early morning hours, as the sun rises, activity begins in the magnetic field. As charged particles from the sun pass through Earth's magnetosphere, electromagnetic waves are emitted. When these waves are converted to sound frequencies, they're high-pitched, chirpy, almost like the sounds of a forest. NASA recorded this sound in 2012 using the Radiation Belt Storm Probe satellite, and when they shared it, people were shocked. Because this sound doesn't sound artificial, it sounds organic. It's as if it's the sound of a living being, as if it's coming from nature. But it's actually a completely physical phenomenon resulting from the interaction between Earth's magnetic field and the solar wind. Think about it for a moment. The planet you live on has a sound, and you've never heard it. Let's turn to the sun. The sun's sound manifests in two different ways. The first is the vibrations on its surface. The sun is constantly oscillating. Giant plasma waves rise and fall on its surface. These vibrations allow us to understand the sun's internal structure, just as earthquake waves on Earth reveal what lies beneath the surface. This is called helioseismology. When these vibrations are converted to sound frequencies, they produce a deep, continuous, low rumble, a sound that's almost palpable, felt more in your stomach than in your ears. The second is the sun's magnetic field activity. Sunspots, solar storms, coronal mass ejections, all of these emit electromagnetic waves, and these waves can also be converted into sound frequencies. The sounds recorded during a solar storm, however, are very different. They are sudden, powerful, and harsh bursts, as if a giant electrical transformer had malfunctioned. And these sounds are important because solar storms affect Earth, disrupting communication systems, satellites, and even power grids. By analyzing these sounds, we try to predict these storms in advance.
Let's take a look at the others, too. Uranus. Cassini's sister mission, Voyager 2, flew by Uranus in 1986. It took measurements of the planet's magnetic field. Uranus's magnetic field is strange. It doesn't originate from the planet's center, but from a point away from the center. And as it rotates, it creates a strangely wobbly magnetic field. When this wobbly field is converted into sound frequency, it's an irregular, clicking, mechanical sound. It's as if an old machine is running. Neptune. Voyager 2 also flew by Neptune in 1989. Neptune's magnetic field is also tilted, like Uranus's, but it has a different character. Neptune's sound is more regular, more rhythmic, low, repeating waves. It's like a whisper coming from far away. Mars. Mars is an interesting case. That's because Mars has no global magnetic field. It died out billions of years ago. But there are local magnetic fields on the surface. The InSight lander touched down on Mars in 2018 and recorded the sounds of the wind. Technically, this is an atmospheric sound, but hearing the sound of another planet is still strange and beautiful. When the sound of the Martian wind is converted to audio frequency, it's a thin, high-pitched, continuous hum. It's like the wind blowing in the desert, but it's much lonelier.
Now let's ask this. These are cool, but what's the point? Actually, they're very useful. Analyzing a planet's magnetic field helps us understand its internal structure, just like a doctor listens to a heartbeat to determine if there's a problem with the heart.
By analyzing Jupiter's radio emissions, we can track Io's volcanic activity. By studying Saturn's sound cycle, we understand the planet's layers. By listening to the sun's sound, we try to predict solar storms. And by analyzing Earth's chorus, we track changes in the Van Allen belts, the radiation belts surrounding Earth. So these sounds aren't just beautiful, they carry information. At every frequency, every rhythm, every sudden change, they tell us about a planet's current state. The universe is speaking. We're just learning to listen.
We said at the beginning, imagine an orchestra. Now you see that orchestra differently. Jupiter is playing the drums, powerful, sudden, unexpected. Saturn breathes with a deep rumble. Earth starts a chorus first thing in the morning. And the sun, high above them all, rings out like a giant, constantly vibrating instrument. And you're sitting right in the middle of this orchestra, on a tiny planet, without hearing a single one of them. But now you know, those sounds are there, every day, every hour, unchanging, unceasing. Perhaps this is the greatest discovery of all, learning that the universe isn't silent, realizing that we just need to know how to listen. So, which of these sounds do you think is the most interesting? Jupiter's storm, Earth's chorus, or Saturn's deep breath? Let's discuss it in the comments.